Hello, this is Sadbir. The topic of our discussion in this video is Introduction to Differential Equation. What is a differential equation? An equation involving derivatives one or more dependent variable with respect to one or more independent variables is called a differential equation. Here I have example of two differential equation. In my first differential equation, my y is dependent variable and x is independent variable. This is another differential equation in which I have y my dependent variable and x, u, and v. There are three independent variable in this differential equation. I can give you more example here. D square y by dx square plus 2 dy by dx plus 2xy is equal to 0 is also an differential equation where y is the dependent variable, x is the independent variable. In this differential equation, you can see you have the higher order derivative of the dependent variable with respect to the independent variable, and you have the dependent variable as well as the independent variable in the equation. Next definition is what is the order of differential equation. The order of the differential equation it defines as the highest derivative in the differential equation. For example, d square y by dx square plus xy square is equal to 0. In this case, the order of the differential equation is 2 because the highest order derivative in this differential equation is 2. And in this example, dy by dx minus y is equal to 0. This is the differential equation. And the order of this differential equation is 1 because the highest order derivative of this differential equation is 1. Now we can also define the degree of the differential equation. The degree of the differential equation is defined as the power of the highest order derivative terms in the differential equation. So in order to find the degree of the differential equation, first you have to find the order of the differential equation. For example, here the order of this differential equation is 1 because this is the highest order term, the highest order derivative of the dependent variable with respect to the independent variable. And it is a degree is 1, the highest order degree is 1. So this is of order 1 of degree 1. So here you can see that the highest order term, the highest order derivative is d square y by dx square. So this one is the first order. So this one is the second. So this is the highest and it is a degree is 1. So therefore this differential equation is of order 2 of degree 1. Here you can see the order, the highest order term is d cube y dx cube because this is the first order term, this is the third order term, and it is a degree is 2, so therefore this is of order 3 and degree 2 differential equation. Here I have one quiz problem for you to practice. Please pause the video for 1 or 2 minutes and work on this problem. Classification of differential equation. The differential equation essentially can be classified into two categories. The one is the ordinary differential equation and then the partial differential equation. In this course, we will study more about the ordinary differential equation. The ordinary differential equation can be classified into next two categories. One is the first order differential equation when the order of the differential equation is 1, or when the order of the differential equation is 2 or higher. And then each of these category again classify into the linear when the differential equation is linear and when the differential equation is not linear. And same is can be classified for the higher order when the higher order differential equation is a linear and when the higher differential equation is a non-linear. You can also further classify the partial differential equation into first order, higher order, linear and non-linear as well. But in this course, we will just focus on the ordinary differential equation. So we will go along the path. First, we will study the ordinary differential equation of first order, and then we will study the linear in that category, and then we will study nonlinear, and then we will move to the higher order and study the linear first and then the nonlinear higher order differential equation. Since in this course we are going to study the ordinary differential equation, so here I will give you the definition what is an ordinary differential equation. An ordinary differential equation involving derivative one or more dependent variable with respect to one or single independent variable. So most important thing in this definition is single variable. It has only one independent variable. So if the differential equation has only one independent variable, that differential equation is known as ordinary differential equation. For example, this is an ordinary differential equation because it has only one independent variable, because all the derivatives are taken with respect to one variable. This differential equation d square y dx square plus dy dx is equal to 0 is also an ordinary differential equation because all the derivatives are taken with respect to one variable. This differential equation dy over dt plus dw over dt is equal to 0. This differential equation is an also ordinary differential equation. Here we have two dependent variable, but all the derivative are taken with respect to one independent variable. Our next definition is what is linear differential equation. A differential equation is linear if dependent variable and its derivatives are of degree 1. And the second condition is the coefficient of the term does not depend on the dependent variable. For example, dy by dx plus y is equal to 0. This is a linear differential equation because all the derivative of the dependent variable are degree 1 and the coefficient of the term does not depend on the dependent variable. So there is no dependent variable in front of the derivative. This is also a dy by dx plus x y is equal to 0. So here you can say that the coefficient is depend on x, but x is not a dependent variable. So this differential equation is still a linear differential equation. Dy by dx plus y is equal to sine x. This is also a linear differential equation. Few example of non-linear means a differential equation which is not linear. So y dy by dx plus y is equal to 0. This is a non-linear differential equation. The very reason is that the coefficient of the dy by d term is depend on the dependent variable. Dy by dx plus y square. This is a non-linear differential equation because the dependent variable has a degree more than 1. Dy by dx square plus y is equal to 0 is a non-linear differential equation because the degree of the derivative dy by dx is not 1, it's supposed to be 1, so the first condition does not met. So this is also a non-linear differential equation. Our last topic in this video is what is a solution of a differential equation. A solution of a differential equation is a relation between variables, independent and dependent, which is free of derivative and which satisfy the differential equation identically. For example, if you have a differential equation dy by dx is equal to x is equal to 0, and if you can find a function y in term of x, in this case I can say 1/2 x square, and this is a relation between the dependent variable, y is your dependent variable and x is our independent variable, which satisfy the differential equation. So as we can see that if I calculate dy by dx, then I will get derivative is 1/2 2x, which is basically x. So if I plug back that into my differential equation satisfy identically. Since dy by dx is equal to x, so x minus x is equal to 0. This implies 0 is equal to 0. So we will say that y is equal to 1/2 x square is a solution of this differential equation. One more example. So if our differential equation is a dy by dx minus 2y is equal to 0. So if I can find a relation of my dependent variable y in term of my independent variable, which will satisfy my differential equation, that function I will call the solution. Here I'm going to guess the solution. So my guess is y is equal to e to the power 2x, because if I calculate the derivative of dy by dx of this function is going to be 2 e to the power 2x. And if I plug back that into my differential equation, so my differential equation is a dy by dx is a 2 e raised to power 2x minus 2 time, what is my y? Y is e to the power 2x is equal to 0. Therefore, 0 is equal to 0. Therefore, this function is a solution of my differential equation. Here I have one more quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. This is also the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.